Hello everyone! In this C++ tutorial, we explain the connection between arrays and pointers in C++. Here is a brief summary of what you will learn in this video tutorial. First of all, we will go over basic theory. We will explain how variables are stored in the memory. Then we will explain how arrays are stored in the memory. And then we will explain what is the connection between arrays and pointers. After that, we explain how to write a simple C++ code that demonstrates the connection between arrays and pointers. Namely, in this tutorial, you will learn that array names are actually constant pointers, and this is very important. Okay, let's start. First, we explain how variables are stored in the computer memory. The classical computer memory is composed of numbered locations. Every numbered location is called a byte, and every byte has an address. Here is an illustration that illustrates bytes and how variables are stored in the computer memory. These slots or these rectangles are particular bytes. Every byte consists of 8 bits, and every bit can be either 0 or 1. And here is an example of a byte. This byte can represent, for example, some number or something similar. Every byte has an address, and the address is represented by this ellipse over here and the number inside. So we can see that this byte has an address, this byte has an address, this byte has an address, etc. A primitive variable or a simple variable is implemented as a segment of the memory space composed of the consecutive bytes. For example, on your computer, integer a will occupy 4 bytes. That is this byte, this byte, this byte, and this byte. And it will occupy 4 consecutive memory locations. Also, on some computers, integers can be, for example, 2 bytes, depending on the implementation, depending on the processor, etc. This implies that a variable is described by an address in the memory that determines the location of the first byte, and number 2, type of the variable, which determines how many consecutive bytes it needs to occupy. For example, when we say or when we declare integer a, the compiler needs to store only the address of the first byte, and it automatically knows that this variable will occupy 4 bytes. This is because integers occupy 4 bytes. Next, we explain how arrays are stored in the computer memory. When an array is declared, the computer reserves the number of memory locations or bytes corresponding to the data type that the array stores and the total number of variables that need to be stored. The locations of array members are consecutively placed in the memory. That is, they are placed next to one another in the memory space. And here is an example. Over here we declared a to be an integer array. Here is the address of the first byte of A0, and A0, since it's an integer variable, occupies 4 bytes. Then immediately in the memory space, the computer will store A1, and this A1 will also occupy 4 memory spaces, and finally we will have A2 that will also occupy 4 memory spaces. And note over here that A and all of its member variables are placed consecutively in the memory space, and this is denoted by this shaded region. The computer only remembers the address of the first byte of the first variable in the array. That is the beginning of the array, and the total number of variables in the array. That is, it does not remember the memory location of every variable in the array or the memory location of their bytes. Then, when the computer needs the address of some other variable, it will simply offset or calculate the address of the first variable. This offset is computed on the basis of the location of the variable in the array. And let's explain this further. When we declare A to be an array of the integer type, the compiler and the complete system need to remember the address of the first byte of A0. Also, they need to remember how many members there are in the complete array. That is, they need to remember this number 3. That is, it's not necessary to know the addresses of the starting bytes of A1 and A2. If we want to access, for example, A1, we just need the address of A0 and then we will simply offset this address for 4 to get to A1. Similarly, if we want to access A2, we just need to remember the address of A0, that is this number over here, and then we will simply offset this number by 8 to come to A2. And finally, we are ready to explain the connection between arrays and pointers. Over here, we declared an array of the integer type A, and this array will store 3 variables. Now, the array name A, or the array variable, is actually a pointer to the memory address of the first indexed variable in the array. That is, it's a pointer to the first byte of A0, and this is illustrated over here. That is, we can use A instead of a pointer to this first address of A0. Next, we can define a new pointer variable like this, int as a pointer p, and then we can write p is equal to a. Now p will also point to the address of the first byte of A0. That is, it will point to A0. And then we can access and modify the members of A, that is A0, A1, and A2 by using p. That is, we can simply access A0, A1, A2, etc. by typing P0, P1, and P2. Now, here's one very important thing to keep in mind. Once the pointer A is defined, it cannot be changed. That is, A is not of the type int as a pointer, it is of the const version of int pointer. For example, this assignment over here is not legal in C++. Why is that? Over here, P1 is a previously declared pointer that points to some other memory address. And since A is actually pointing to this address, we are trying to reassign A to point to some other address that's being pointed by P1, and this is not illegal. That is, you cannot reassign A to point to some other memory address. And always keep in mind this. Okay, let's start with coding. First of all, open your favorite C++ editor. In my case, I'm using Visual Studio Code. And let's start with coding. First of all, let's include input-output stream. And after that, I will simply type using namespace std to simplify my code. And here's my main function. And I always like to return 0. Over here, we will declare an array A that will store integers, and I will declare an integer pointer P. Let's fill in the entries of A. So let's write for int index is equal to 0, then we will have that index is smaller than 10, and we are going to write index plus plus, and inside over here we will simply say A index is equal to index. Good. Now look what I will write. I will write this, P is equal to A. Now what's happening over here? Since A points to A0, that is, to the first entry of our A, P will also point to A0, and we can use P to perform operations on A. First of all, let's test this. Let's try to print all the entries of A by using P. And let's write it down. Again, I will just copy this part over here to save some time. So write a for loop, and inside of this for loop, we will just print the entries of A by using P. So we can write C out, and then we can write P, we can index it, and we will add some empty space over here, and after that we will simply end the line. Before I compile this, note the following. Note that I am using P index to access A. That is, although P is actually a pointer, you can use array notation in the case of P. This is very important to keep in mind. Okay, let's compile and run this code. And over here, I'm going to use a simple command prompt to run my code. And here it is. Note over here that we are printing the members of A by actually using P. Next, let's change the values stored in A by using P. And here is again a simple for loop, and in this for loop I will type P of index is actually 2 times index. And let's see what will happen. To see the effect, we again need to print out the values stored in A, and for that purpose we will again add another for loop, and over here in this for loop I will use A instead of P. So let's summarize. Over here we are changing the values stored in A by using P, and over here we are printing A by using A. And let's see what will happen. Let's now compile this. And over here I will run again my code. Let me now go back here and I will type test2 and let's see the output. Okay, we can see that the outputs are actually changed and they are doubled. These are the original variables and these are the change variables. You can see the power of pointers. Okay, that's all for today and thanks for watching.